Hello and welcome to this explainer. Okay, I want you to picture something for just a second. Imagine our guide for today, a rather stressed out cartoon T-Rex, acting as your traditional systems administrator, right? And this poor T-Rex is trying to manually sift through network logs to find a security threat. Now imagine trying to do that in a modern AWS environment. We are literally talking about gigabytes of VPC flow logs, just endless DNS queries, and millions of CloudTrail events firing off every single minute across thousands of ephemeral instances. Picture those tiny dinosaur arms frantically flipping through endless pages of raw JSON data just to spot one single malicious IP address. It's an absolute prehistoric nightmare. For a long time, trying to secure a network felt exactly like that. Manual log analysis is slow, it's prone to human error, and honestly, in the era of cloud computing, it's completely primitive. You just can't scale manual human effort to match the speed of cloud-native attacks. But today, we're giving our dinosaur friend a massive upgrade. We are ditching the Stone Age struggle and stepping right into the realm of futuristic, AI-powered threat detection. We're taking a deep dive into AWS GuardDuty. Okay, let's dive into this. Here's our roadmap for today. First, we'll meet AWS GuardDuty. Second, we're understanding severity levels. Third, spotting common security findings. Fourth, the investigation workflow. And finally, cloud security best practices. Section 1. Meet AWS GuardDuty. So, think about the fundamental problem of guarding a modern digital cave. It requires way more than just a big, fierce physical presence at the front door. The sheer volume of data going in and out means you absolutely need massive automated data processing. You can't just stand guard anymore. You have to outsmart the threats. By definition, GuardDuty is an AWS threat detection service. But the real game changer, the true evolutionary leap here, is exactly how it operates. It uses machine learning combined with integrated threat intelligence. Let's think back to our T-Rex for a second, trying to read every line of code. If our T-Rex sees an IAM role assuming temporary credentials, well, it might just think that looks like a normal Tuesday. It doesn't have the capacity to remember the context of every single previous login. GuardDuty's machine learning, on the other hand, constantly ingests those massive, overwhelming amounts of complex logs. We're talking CloudTrail, VPC flow logs, DNS logs, EKS audit logs, and S3 events. It takes all that chaotic data and establishes a continuous mathematical baseline of your environment's normal behavior. So if those same temporary credentials are suddenly used from a brand new IP address halfway across the world, or maybe at a highly unusual time of day, GuardDuty flags the anomaly instantly. It's essentially your tireless high-tech sentinel, replacing those tiny little arms with vast neural networks. Section 2. Understanding severity levels. Now, not every shadow in the cave is a monster, right? GuardDuty categorizes danger for us, so security teams know exactly when to casually monitor a situation and when it is absolutely time to panic. Look, in a noisy cloud environment, alert fatigue is a massive, massive problem. If a security operations center has to chase down every single minor anomaly, the analysts are going to burn out fast, kind of like an exhausted T-Rex chasing its own tail. GuardDuty prevents this by structuring alerts into a very strict threat matrix. At the top, we have low findings. These generally indicate unusual activity that simply requires you to monitor things. Then we step up to medium, which points to activity deviating significantly from your baseline, and that requires investigation. Things get really serious at high, demanding immediate attention. But then we hit the bottom row, critical. A critical finding is not just a guess. It indicates an active compromise or ongoing data exfiltration. Think of an EC2 instance that is actively beaconing out to a known command and control server. This is literally an extinction-level threat for your data, requiring an urgent response. GuardDuty handles this prioritization automatically, saving your security team a ton of precious time. Section 3. Spotting common security findings. This brings us to the rogues gallery of threats that our high-tech shield is constantly looking out for. Just imagine our dinosaur guide trying to spot a Trojan on the network. I mean, it's practically invisible to the naked eye. But GuardDuty doesn't just look at raw traffic. It correlates DNS requests against global threat intelligence feeds. So if it sees your server asking for directions to a known malicious domain, bam, it fires off a Trojan-EC2 alert. And it provides similar deep-level detection across the board. You might see unauthorized access.im user pop up, meaning someone is knocking at the door with stolen keys, perhaps detected through impossible travel metrics. Or maybe recon-EC2/port scan, where an attacker is actively probing your defenses for open vulnerabilities. It even catches cryptocurrency.ec2/Bitcoin tool. And it doesn't just spot this by looking for a high CPU load. No, it actually pairs that compute spike with VPC flow logs showing outbound network traffic routing directly to known Bitcoin mining pools. These punchy, highly specific alerts tell you exactly what the threat is, the mechanism of action, and where it's happening. It completely eliminates the need to manually dig for context. Section 4. The investigation workflow. Okay, but knowing a threat exists is only half the battle. So, a critical threat is found. Now what? If GuardDuty spots an active compromise, what is your very next move? You can't just freeze up like a deer or a dinosaur in headlights. We have to pivot right now from theoretical detection into hands-on defensive action. This requires a perfectly structured, highly methodical investigation process. Step 1, review the finding details. You need to parse the JSON output of the finding to understand the exact threat mechanism. Step 2, identify the affected resources. You pinpoint the exact Amazon resource name, or ARN, of the compromised server or user role. Step 3, analyze the logs. This is where you might use a tool like AWS Athena to run SQL queries directly against your CloudTrail logs, looking for the specific API calls the attacker made right around the time of the alert. Step 4, validate the source IPs. You cross-reference the attacking IP address against external threat intelligence databases to understand the actor behind the attack. Step 5, determine legitimacy. You check in with your development teams. Is this a real malicious attack or just a developer running a weird stress test script on a Friday afternoon? Finally, if a compromise is confirmed, step 6, remediate. This is where you neutralize the threat. You might attach a strict denial security group to an infected EC2 instance, totally isolating it from the internet, or immediately revoke the active IAM sessions for compromised credentials. This workflow turns absolute chaos into a controlled, manageable, and highly technical response. Section 5, Cloud Security Best Practices. Now that we know how to fight the fires, let's talk about preventing them in the first place. This is how cloud security teams proactively secure their setup so those critical alerts rarely even happen. First off, enable GuardDuty across all regions. Listen, attackers love to spin up malicious resources in regions you rarely use, just hoping you won't notice their shadow IT. Integrate it with Security Hub for a centralized, single pane of glass view across all your accounts. Configure your alerts properly. Maybe route them to a dedicated Slack channel or PagerDuty so your team is actually notified. Then you have the absolute foundational rules. Enforce multi-factor authentication and use strict least privilege IAM policies so that even if credentials are stolen, the blast radius is minimal. Finally, automate your remediation. Remember our T-Rex, a manual admin with tiny arms, simply cannot type fast enough to stop an automated scripted attack from exfiltrating data. That is exactly why you use a service like AWS EventBridge to listen for specific GuardDuty findings, which can then instantly trigger an AWS Lambda function to isolate the compromised resource in milliseconds. You fight machine speed attacks with machine speed defensive. By letting AI do the heavy lifting of continuous baselining and threat intelligence analysis, you actually free up your security team to do what they do best, engineering robust, proactive defenses. Continuous monitoring stops threats before they become extinction-level events. AWS GuardDuty empowers organizations to leave those prehistoric methods entirely in the dust. You really don't have to rely on manual, tedious log parsing anymore. By leveraging advanced machine learning, understanding the distinct severity of your alerts, and following a strict technical investigation workflow, you can secure your modern infrastructure with absolute confidence. So take a look at your own AWS environment today. Are you evolving your security at cloud speed, or are you just waiting for the asteroid to hit? Thank you so much for joining me for this explainer.